Calculus Lesson 3. It's going to be on basic differentiation, which is just a continuation of our last lesson where we learned the standard steps that we take in terms of bringing down the power, minusing 1 from the power. Should be simple enough. Now, where it could get a little bit harder, the types of questions they could ask us, is when the indices that we were using are actually negative or fractional indices. The exact same rules apply, it's just a little bit more working with the actual equations. But we'll get into it. It's a tad boring and a little bit monotonous, this part, but we've got to push through it because they will ask you questions that will try and test your understanding of this. So we're going to push through with negative and fractional indices. Let's start off with negative indices. For example, they ask you to differentiate y equals x to the negative 3. Exact same rules apply as before. Nothing changes. Don't be intimidated by negative or fractional indices. Work on the exact same way in you bring down the power and you minus 1 from the power. So the derivative is going to be bring down the power minus 3 minus 1 from the power. So just don't forget that minus 3 minus 1 is minus 4. That's an area that some people sometimes stuff up on, is that they add 1 instead of continuing to minus 1 from the power. Now that's the derivative. The key to both negative and fractional indices every time is always converted into index form. So the one we just did there, x to the negative 3, is in index form, and that's why it was so easy. However, you'll often get ones that aren't in index form. You'll get it as a fraction, such as there. Now I've just written it there in general form, 1 on x to the n, that could be any number, 1 on x cubed, 1 on x to the 5. Now what 1 on x to the n becomes is x to the negative n. That's index form. So if it's as a fraction, you want to convert it into index form. Always, always, always. You can only differentiate when it's in index form. And so fractions, as you can see, become negative indices. And in terms of how that works, we have done it in the past in terms of indices, but I'll run through that quickly now because it's important and people find this really difficult for some reason. So, for example, we've got 3x to the 4 on 2, or 3 on 2 x to the 4. What we're going to do in order to change that back and forth, we want the term, just the term with the index to go up or down. So the numbers stay strong, they don't budge. The 3 on 2 stays there. It's just going to be the x to the 4 that goes up and down. And when it goes up or down, you give it or take away a negative. So for example, the x to the 4 goes down and you give it a negative. Or you bring it up and you take away the negative. Take it down, give it a negative. Bring it up, take away the negative. That's exactly how it works. Ignore the numbers. Don't let them change anything about it. So another example, 4x to the negative 2. Now this is working backwards, so we want to get rid of the negative indice and we want to put it into a fraction because you need to be able to go back and forth. So what will happen is the 4 stays strong. It's just going to be the x to the negative 2, or the x to the 2 that goes up and down and gives or takes away that negative. So x to the negative 2, the x squared goes down and the negative disappears. Or the x squared comes up and you give it a minus. Or the x squared goes down, negative disappears. X squared goes up, give it a minus. And so on. That's just the way it works. You want to get really good at that so you're not sort of battling during the questions to manipulate it and change it into index form. But the key is always, always, always get it into index form in order to differentiate it. You may need to reverse the process and go back into fraction form at the end to express your answer, but in order to differentiate it, always convert it into index form. Let's try an example. Differentiate f of x equals 1 on x to the 5. Now, first step, as we discussed, always convert into index form. I've added all those rules to our sidebar there so we don't forget. But always convert it into index form. So what happens? The the index with the x can go up or down, and you just give it or take it away a negative. So the x to the 5 will come up, and you'll give it a negative. So it's x to the negative 5. Now we can differentiate that. Derivative becomes minus 5x to the negative 6 because we brought down the power and minus 1 from the power. Simple as that. And that is the derivative. All they can do to maybe extend the question is ask you to express it without negative indices. Now this is where you want to be good at going back and forth with what we were just doing. So being able to turn it into index form or go back into fraction form. So here we've got a negative indice, we want to get rid of it. So what do? We take the x to the 6 and put it to the bottom, which will get rid of the negative. So it becomes minus 5 on x to the 6. Done. Another example. And this one is a good opportunity for you to pause me here and try it yourself, as you can see by the icon in the top. When you're ready to go, differentiate y equals 2 over 3 x to the 9. Okay. Now we notice we can't differentiate that in that form. We need to get it into index form. So we need to bring the x to the 9 up, which will end up giving us a negative index because that's how it works. You bring it up or down, give or take away the negative index. So we got 2x to the negative 9 on 3. Now when we differentiate, we bring down the power, minus 1 from the power. So when we bring down the minus 9, it times us by the 2/3. So we get minus 18 thirds, or minus 18 on 3, x to the negative 10, because we minus 1 from the power. So hopefully that makes sense. We then tidy that up, and that becomes negative 6 x to the negative 10. That's the derivative. Again, they can make it a little harder by saying express it without negative indices. But now we're starting to get good at this. In order to get rid of the negative indice, put it on the bottom and you can take it away, and vice versa. So that becomes negative 6 on x to the 10. Time for fractional indices. Such as differentiate y equals x to the 3rd, a fractional index. Guess what? Nothing changes. Bring down the power, minus 1 from the power. Same. So we bring down the power. It's a 3rd x to the, and now we minus 1 from the power. So we minus 1 from a 3rd, which leaves us with negative 2/3. Because 1/3 minus 1 whole is going to be negative 2/3. If you're unsure, put it in your calculator. But that's the derivative. Again, it's relatively easy so long as you always convert it into index form. If you're in index form like that, it's relatively easy. The way we do that is, we've done this in the past with index laws, but remember, roots become fractional indices. And so the nth root of x to the q actually becomes x to the q on n. I know there's q's and n's and all that sounds intimidating, but I use it in general form so we can apply it. And I'll do that in a sec with real numbers. But the important thing to note is that the number of the root lands up becoming the denominator, and the x to the power of, so the power index, lands up becoming the numerator. But in number form, I'll show you that now. So we've now got the cubed root of x to the 4. That becomes x to the, so as I said, the 4, the power index, stays as a power index on the top. And the root, and a nice way to remember this is, where do the roots grow? Under the ground. So they go under of the fractions. So you see that slides down under the 4. So it's 4 on 3. Let's try another one. The square root of x cubed. And so it's x to the power of, we know that a root is going to become a fractional index. Now we know the power index, so the current index of the x stays as the power index. It stays as the numerator. And the root, because we know roots grow under the ground, the root goes down as the denominator. Because it's the square root, even though there's not a 2 there, square root means the second root. So it's a 2 on the denominator. So it's x to the 3 on 2. Okay, what about if they give it to us in fraction form? So the reverse process, we need to be able to go backwards like we were doing with the negative indices. So they give us x to the 2 on 5. How do we put that back into a root? Well, because we know roots grow below the ground, we take the below number, the 5, and it becomes the 5th root. And the top number, the power index, the numerator, stays as the index of the x. So that's at the top, and that's x squared. Okay, we're ready to tackle a couple examples now. Alright, differentiate the square root of x cubed, which is what we just touched on before, but we didn't go through the process of differentiating it. The first and most important thing, which is what we were doing before, is convert it into index form, which I want you to think about now. You should know that because we just did it. The square root, remember roots below the ground, so it's the bottom part of the fraction, the denominator. And the top, the x cubed, the cubed stays on the top. So it becomes x to the 3 on 2. So that should be making a bit more sense. I won't go as slowly anymore. I'll start making that a little bit more speedy process. So, but now that we've got that, we've got x to the power of 3 on 2, we now differentiate that. So we bring down the power, minus 1 from the power. So we bring down the 3 and 2, and we minus 1 from 3 and 2. Now remember, 3 and 2 is 1.5. So minus 1 from 1.5, and you're left with a half. Again, if you're not sure, use your calculator, but that's the derivative. 3 and 2, x to the half. Again, they could ask you to express it without fractional or negative indices. So we need to be able to reverse the process. So what we do, I just like to emphasize that the x to the half is on the top, obviously, because it's times by. So I just rewrite it as such. 3x to the half on 2. Now x to the half, working backwards, we know that a fractional index goes backwards to a root. And x to the half, which is going to be your sort of default one, we know becomes root x, because the denominator is a 2, so it's the square root, and the numerator is a 1, so it's x to the 1. So it's 3 root x on 2. Hopefully that was slow enough. If not, look through it again and try to take it one step at a time. Next example. Differentiate the 4th root of x. So, surprise, surprise, first and most important step, because you can't differentiate it if you don't do this, convert it into index form. That becomes x to the quarter, because the root becomes the denominator. The power stays as the numerator. Okay, now we differentiate that. So we bring down the power, minus 1 from the power. When you minus 1 from a quarter, it becomes negative 3/4. Perfect, but they again may ask us to express it without negative fractional indices. Now they don't always do this. I'm just asking you every time to do it because I want to make sure you're good at that reverse process, that you are good at getting negative or fractional indices and getting out of them if need be. So how do we do that? Well, the first thing we've got there, we've got that negative index. So let's get rid of that. We'll take the whole x and its indice to the bottom and get rid of the negative. So that becomes 1 on 4x to the 3/4. Now we want to change the fractional index back to a root. So because it's 3/4, it becomes the 4th root of x to the 3. So it's 1 on 4 times the 4th root of x cubed. Looks kind of ugly, but we need to be able to work it through to that. Speaking of ugly, that there is most certainly an intimidator, and it is quite tough because there's lots of numbers, there's lots of working, but let's go one step at a time. Do not skip steps, and let's work through this. So we've got y equals 5 on 7 times the cubed root of x squared. A real mouthful, but let's go. First things first, only way we could differentiate this is if we take it into index form. So 5 on 7 stays as is. We're just going to convert that root into a fractional index. Because it's the cubed root, the 3 is on the bottom, and because it's x squared, the 2 is on the top. So it's 5 on 7x to the 2/3. But now we can't work with the x index on the bottom. We need to bring that up. And if we bring it up, we got to give it a negative. So that becomes 5x to the negative 2/3 on 7. So that's two big steps of working. We haven't differentiated yet. We've just manipulated it in order to give it a negative and a fractional index. Because once we're here, now we can just differentiate it like we've been doing. Bring down the power minus 1 from the power. But let's take this part slow. When we bring down the power, that minus 2/3 times us by that number that we had before, which is the 5/7. And we minus 1 from the power, so it becomes x to the, I've just done it in mixed numbers because it's easy to see, but it's minus 2 on 3 minus 1. So it becomes minus 1 and 2/3. I'll put that into improper fraction in the next step because it's much easier to work with improper fractions. But let's work it all through at once. So we can times those two numbers together now, and that becomes negative 10 on 21. And our indice, negative 1 and 2/3, we could turn into an improper fraction, and that is negative 5 on 3. Okay, you should know how to turn mixed numbers into improper fractions. Times by the bottom, add the top. Okay, so we've got negative 10 on 21, x to the negative 5 on 3. And that is the derivative. It's tough, but it's not impossible. And that is one of the harder questions because there's a lot of confusing elements. The only last thing that they can add, as I've done with all the other questions, I just want to make sure that you're able to convert it back without negative and without fractional indices. So first things first, let's get rid of that negative indice. Let's bring it down. Becomes negative 10 on 21, x to the 5 on 3. Now we need to turn that fractional indice to a root. So because it's a 3 on the bottom, it becomes the cubed root. Because it's a 5 on the top, it becomes x to the 5. So it's negative 10 on 21, the numbers stay the same, but x to the 5 on 3 becomes the cube root of x to the 5. A real tough question, but if you follow in that and you take it one step at a time and it's making sense, trust me, that's as hard as they can get in terms of these fractional negative indices. And they're a bit annoying because it's numbers up and down and fractions and negatives, and it's all playing with these numbers, and this is far from the most fun you're going to have in maths. But if you are following it and you're doing alright with this, you are killing it.